Hello, welcome to Carbon Chemistry, naming organic substances. So in this one we're going to learn how to name organic substances. This is the information that's on your information sheet. So there's the general formulas for alkanes, alkenes and alkynes, and also the formula for cyclic alkanes. You also will find on the same page what are referred to as the organic stem names, which goes with the number of carbon atoms in the chain from 1 to 10, and these are the stem names. And you'll also find the names for the side chains and the substitutes. So we can have side chains of methyl, ethyl and propyl, and these are the condensed semi-structural formulas for them, and these are the names for if we have any of the group 7 elements, the bromine, chlorine, fluorine and iodine, but their names are given like that in organic chemistry names. So just make sure you've got this handy, because we're going to be using it a lot when we're doing these naming questions. So get out your information sheet and have a look at that page. Make sure you don't confuse it with another list of prefixes that we used when we were naming covalent molecular substances. So, naming organic substances. Now there's a whole list of rules. I'm going to give you 6 rules and we'll run through them, and then we'll do some examples. They're fairly logical. There's a couple of twists in there, but with a bit of practice you should be okay. So the first rule is determine the longest chain of carbon atoms, and that will determine what's called the stem name. You then determine which end is nearest to any branch or double bond or triple bond, and if you do have a double bond or a triple bond, that takes precedence. So that means it's superior to any branch if they are equidistant, so if they're the same distance from either end of the chain. So if you have a double bond that's on the second carbon, but you also have a branch that's on the second carbon, the double bond takes precedence. Rule 3, number the carbon atoms from the end chosen. So if you've got a double or triple bond, that determines the end, otherwise nearest to a branch. Name all branches first. Now with the branches you use the ending "il", so you still use the stem names to tell you how many carbons are in the branch, but you then end it with "il". So methane means a carbon branch of only 1 carbon, so that becomes methyl, whereas ethane means 2 carbons in the branch, and so it becomes an ethyl. And then the longest chain, so name any branches first with the ending "il", then the longest chain, then any single or double bond, and that's the order that your name goes in. When 2 or more branches occur on the same carbon atom, the number of the carbon atom is indicated for each branch with the names given in alphabetical order, and we'll see what all this means in a couple of examples coming up. When 2 or more identical branches occur on different carbon atoms, the prefixes di, tri or tetra are used. So that's when they're on different carbon atoms. But if you've got 2 methyls and they're coming off 2 different carbon atoms, you would be dimethyl. So let's just do an example. Here's our chain, so we look at it quickly. We've got 1, 2, 3, 4, 5, 6, 7 carbons in the chain, and we've got a double branch there. And the other thing of interest is this guy here, which is 1 carbon branch, or a branch, and it's got 1 carbon in it, so that's going to be meth, and because it's a branch it's going to be methyl. And notice that the numbering here, we number so that the double bond has the lowest possible number, and when we identify the double bond we use the 2, not the 3. So it's the lowest possible number that we can give to the double, or if it was a triple bond. So the longest chain has 7 carbons, therefore we look it up and we see that it's hep. There's a double bond, okay, so that means it's going to be an ene, and it's nearest the left hand end, so we number from that end. There's a branch of 1 carbon on number 5, so that's why we numbered that one, and that's going to be 5. That's going to be referred to as 5-methyl, because we could have branches off other ones. In this case we don't, but we could. And there's a double bond, so this double bond is identified as 2-ene because it's a double bond. So all up, the name becomes 5-methyl hep 2-ene, and notice where the dashes are. And you sometimes can put a space in there if you want to. We don't get too pedantic about that. So hopefully you understood that. Let's do another example, and this time I'm going to draw on it if my pen lets me. Fantastic. So they've already numbered it. There's a little hydrogen bond there, but notice that we've got a branch there and we've got a branch there, and we should also note that we've got a double bond there. Okay, so in this case we're going to have to number it from this end. So there's some numbers here already, some have disappeared. We go 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is going to be, because that's 1 carbon, that's going to be a methyl, and it's coming off number 4, so we're going to call that 4-methyl. This is going to be an ethyl, alright, because it's an ethene, it's an eth, it's got 2 carbons in it, and because it's a branch we give it an il, and that's also going to be a 4. Okay, now notice that this guy could also have been drawn like this. Okay, we could have expanded it and drawn it fully exposed like this. So there's our 2 carbons, and if we count the hydrogens, we've got 5 hydrogens. So could have drawn it like that. And then this bond here, or the double bond, that's going to be an ene, but it's going to be a 2. And so now we've got to construct these guys. Now the 8 carbons tell us that it's going to be an oct. Whoops, an oct. Okay, so now we've got to put these things all together in the right order, and we'll go through an example. It's going to do it in a sec for us anyway. Here we go. Okay, so solution. The longest chain is 8. That's where the oct come from. The double bond is nearest this end, so we number from this end across. If we'd numbered from this end, we would have got the numbers wrong, so that's a bad thing to do. If we number from that end, we've got a branch, we've got a 4-methyl, we've got a 4-ethyl, we've got the double bond, which is 2-ene, and the 2 branches of carbon atoms on number 4 have the same number, and therefore we have to write them alphabetically. Do we remember that rule? So that's why it becomes 4-ethyl 4-methyl, and so the whole name of it is 4-ethyl, 4-methyl. I would put a space in there, oct 2-ene. Pretty long name, but if you sent that to any other organic chemist, they would be able to draw exactly that molecule, and that's the point of the exercise, really. So just expanding on it, this tells us the location of the branches, this tells us the names of the branches and the length and the size of the branches. That's the longest chain, that's the location of the double bond, and that's the name because it has a double bond. So name the following, and here we could actually, we notice here that we've got what looks like a chain there, we've got a chain there. The longest chain, we could recognize that could be the longest chain. We could have also have said that that is the longest chain. We could have also said that this is the longest chain, and we could have said that, now what other one? This one is the longest chain. Okay, but even if we picked any of those colours, we would come up with the same name. In this case, let's just get rid of it. In this case, they've chosen this to be the longest chain, so therefore, now that's a 3 there, therefore they're going to, we have to name anything that isn't on the longest chain as a branch, and we're going to number it so that we have the lowest possible numbers for our branches. And in this case, because we've got 2 branches coming off here, no matter which way we drew those different lines, these are going to both be numbered 2, because if we numbered from this end, they would be 1, 2, 3, and 3 is not as small as 2. That means that this branch needs to be a 2. Now these are all methyls, so this is going to be methyl 2, and then methyl 3, or 3-methyl to be more precise. Let's get rid of that. So if we do this, okay, the longest chain has 4 carbons in it. That's where we get a but from. There are methyl groups on carbons 2 and 3. 2 of them occur on carbon 2 and 1 on carbon 3. So we number from that end, the end that has the most, and we give the number of the carbon atom each time the methyl group occurs in the carbon name. We use the tri to indicate the total number of methyl groups, and so all up the name is, and if we do this, 2, 2, 3 trimethyl butane, and the ane tells us there's only single bonds in that longest chain. Okay, hopefully you understood that. I might have confused you with the fact that we could draw different chains, but because this is a 2-dimensional representation of 3 dimensions, that is valid, and you can experiment. If you have any doubts, try a different stem and then name the groups, and I bet you come up with exactly the same name. So now we should be able to do in class what's called naming sheet 1 and naming sheet 2, and they're up there on the OneNote already. So in the next video we're going to look at semi-structural formulas. Cheerio.